Hello and welcome back. Let's talk about line integrals more in depth, I guess, or more simplified, however you want to put it. But how we're thinking of it now is instead of a line integral with respect to arc length or the entire curve, sometimes we want to just look at it in terms of x or in terms of y. So I'll refer back to my sculpture, I guess you could call it. We have our y-axis here. If we view it straight on like this, just like that, we can see that we basically just have a regular integral. And so that's kind of how we can think about this. And the same way, if we looked at it on the x-axis, we'd have a different integral. But, of course, it would still be the same idea. So this is our formulas for it, and they're really quite simple. Back when we talked about ds, we had a very complicated square root and things like that. But now we just take the integral, line integral, of our multivariable function with respect to x, and we times it by dt over dt to get this very simple derivative of x with respect to t. And then we can evaluate the entire integral with respect to t and substitute x and y for our parametrization for r of t. And similarly for y, we just replace x with y. So I suppose we could get into a quick example here. Let's take the line integral over c of xy dx, where c is the line segment, or no, we'll say it's the segment of y equals x squared from x equals 0 to x equals 1. So we can sketch our curve here. It's just this. And it's going to be a very easy parametrization. It's going to be r of t, that's really bad r of t equals t squared. We remember this from our parametrization segment. So let's substitute here. We have t running from 0 to 1 because x runs from 0 to 1 and x is just t. So we have 0 to 1, x is t, y is t squared, t times t squared is t cubed. dx dt here, we take dx dt so that we can then have it replace this with a dt. dx dt is just 1, so we can actually just replace it with a dt. And this is very simple. It's 1 over 4 t4 evaluated from 0 to 1. This is just 1 over 4. So really, really quite simple. It definitely simplifies our integrals, and we'll see in the next video where we will talk about an even easier simplification with Green's theorem. And then we'll get into the real world applications more with vector fields, of course. So thanks for watching.